A city of 8 million people, and in one terrible moment, a neighborhood froze in chaos. On the morning of February 5, 2016, a sound like a bomb blast ripped through lower Manhattan. It wasn't an attack. It was the sickening sound of nearly 200 tons of German-engineered steel folding in on itself. A crane, so colossal it could build skyscrapers, lay twisted and shattered across Worth Street, crushing cars, damaging buildings, and tragically taking a life. The machine at the center of it all was a Liebherr LR 1300 SX, a titan of the construction world. The price tag for the failure? A staggering $20 million. How could a machine built for precision and power fail so spectacularly? What lethal combination of wind, weather, and human decision-making brought this giant to its knees and a community to a standstill? This wasn't just an accident. It was a lesson written in steel and paid for in tragedy. This is Hard Hat Industries, where heavy machinery comes alive. Before we can understand how it failed, we first have to understand the machine itself. The Liebherr LR 1300 SX is not just any crane. It's a crawler crane, a specialist machine designed for the heaviest lifts on the most demanding job sites. Think of it less as a piece of equipment and more as a mobile industrial powerhouse. Its vital statistics are staggering. The LR 1300 SX boasts a maximum lifting capacity of 330 US tons. This immense capability is engineered for the heaviest lifts on large-scale civil and industrial undertakings. To achieve this, it relies on a complex system of counterweights, totaling up to 124 US tons at the rear and another 68 US tons of car body counterweight to keep the machine stable. But its real advantage is its reach. The main boom can be configured to stretch over 465 feet into the air. When equipped with a luffing jib, its maximum system length extends to an incredible 561 feet. That's nearly the height of the Washington Monument. This is the kind of machine you bring in when you need to lift massive components to the top of a 40 or 50-story building. Underpinning all this power is a sophisticated control system. The operator sits in an ergonomic, air-conditioned cab with an electronic control system, a proprietary Liebherr technology that provides real-time data on wind speed, load angle, and ground pressure. Every single lift is calculated by a computer to ensure it stays within safe operational limits. The entire machine, weighing hundreds of tons, moves on a pair of massive crawler tracks, allowing it to reposition on a job site without the need for disassembly. A machine of this caliber represents an investment of between $2 and $3 million, brand new. It is the pinnacle of lifting technology, designed for strength, precision, and above all, safety. It's a machine trusted on high-stakes projects around the globe, which makes what happened on that cold February morning all the more shocking. For the operators and engineers watching, what's the most impressive piece of machinery you've ever had the chance to work on? Let us know in the comments. The morning of February 5, 2016 was not a good day for high-rise construction. Snow was falling, and more importantly, winds were gusting. By 8 a.m., sustained wind speeds were hitting 20 miles per hour, and gusts up to 25 miles per hour. The crew on Worth Street knew they had a problem. The Liebherr LR 1300 SX was in the process of being lowered, its 561-foot system raised high over the street. The protocol in such high winds is clear. You have to get the boom down and secure the crane. The operator, an experienced professional with years at the controls, began the slow, methodical process of lowering the massive lattice boom. But as it descended, a catastrophic principle of physics came into play. With the boom angled low, the massive surface area of the structure acted like a sail, catching the wind. The crane began to weather vane, turning with the wind as it was designed to, but the forces acting on it were becoming uncontrollable. Inside the cab, the operator would have been fighting for control, but the machine was now at the mercy of the elements. The immense lateral force of the wind, pushing against the side of the boom, began to exceed the crane's structural limits. Suddenly, and without warning, the steel gave way. The main boom buckled and folded, initiating a domino effect of catastrophic failure. The entire structure collapsed in less than 10 seconds, slamming into the street below. The impact was so violent it crushed parked cars and damaged nearby buildings. Tragically, David Wicks, a Harvard-educated mathematician, was walking to work. He was killed instantly when the falling crane struck a parked car near him. It was a stark reminder that the physics of failure are unforgiving, and when they are unleashed in the heart of a dense urban environment, the consequences are devastating. The crew was following procedure to lower the crane in high winds. Was this a freak accident or a failure in risk assessment? Where do you draw the line in those conditions? The human cost was, of course, incalculable, but the financial cost was staggering. So how do we get an estimated figure of $20 million? You have to break it down. First, there's the machine itself. The Liebherr LR 1300SX was a total loss. At a value of around $3 million, that was the first major item on the bill. Second, the cleanup. You can't just haul away a nearly 200-ton crane. It had to be painstakingly disassembled on site. Specialized crews worked around the clock for over a week, cutting the mangled steel into transportable sections. This required other heavy-lift cranes, flatbed trucks, and a huge labor force, all working in the middle of a New York City winter. The cost of this complex and hazardous operation ran into the millions. Third, the direct and indirect damages. The collapse severed underground water mains and gas lines, requiring extensive and costly repairs by utility companies. It damaged the facades of historic buildings along Worth Street. Several parked cars were crushed. The significant economic disruption from closing a major thoroughfare in Lower Manhattan for over a week had a massive ripple effect, costing local businesses millions in lost revenue and delaying a major construction project. Finally, the legal costs and settlements. The family of David Wicks filed a wrongful death lawsuit, which resulted in a multi-million-dollar settlement. Numerous other lawsuits were likely filed by property owners and businesses for damages and interruption. When you add up the cost of the asset, the cleanup, the repairs, the economic disruption, the project delays, and the legal fallout, the $20 million figure becomes chillingly clear. It serves as a brutal economic lesson. In the world of heavy construction, an accident is never just an accident. It's a multi-million-dollar event with consequences that stretch for years. In a collapse of this scale, which factor do you believe ultimately costs more? The direct cleanup and repair, or the long-term legal and economic disruption? In the wake of the disaster, the city faced a critical question. How do we prevent this from ever happening again? The investigation by the New York City Department of Buildings exposed critical gaps in the city's crane safety regulations. The collapse of the LR 1300SX became the catalyst for the most sweeping overhaul of crane safety rules in a generation. Before the collapse, the rule of thumb was for cranes to cease operations when winds hit 30 miles per hour. The investigation concluded that this was not stringent enough. The city implemented a strict new mandate. All crawler cranes must now stop work entirely when sustained winds exceed 20 miles per hour. Furthermore, at gusts of 30 miles per hour, the boom must be fully secured. To enforce this, the city now requires every crane of this type to be equipped with a digital anemometer to measure wind speeds in real time. This data must be logged and made available to city inspectors. The decision is no longer left to subjective judgment. It is dictated by data. But the new rules went further, addressing the specific phase of operation that led to the collapse. New regulations were put in place governing how and when cranes can be moved or traveled on site, requiring detailed, site-specific plans to be approved by the city. This ensures that every move a crane makes is pre-planned with safety as the absolute priority. The intro to this video asked how a modern marvel of engineering could fail so catastrophically. The answer is that the machine itself didn't fail. The protocols that governed its use failed. The tragedy on Worth Street forced an entire industry to reevaluate its relationship with risk, leading to a new era of oversight. It was a painful, costly, and ultimately fatal lesson. But its legacy is a set of rules designed to ensure that no family, and no city has to go through that again. Do you think the new regulations in NYC are a necessary evolution for safety, or do they create unnecessary red tape that slows down vital construction work? From a marvel of modern engineering to a fatal miscalculation in brutal weather, the 2016 crane collapse serves as a powerful case study. It highlights the immense power we can harness with these machines, but also the incredible responsibility that comes with it. A $20 million price tag and a legacy of new safety regulations are a stark reminder that in this industry, the stakes are always as high as the structures we build. Thanks for watching Hard Hat Industries, your source for serious machines doing real work. If you like this, hit like, subscribe, and turn on notifications so you don't miss what's next. Until then, keep your head down and your gear running.